Channel. Today let's look at the lead code question. The description of the question is fairly simple, that we were given two integers. N and k. We need to return the kth smallest lexicographically ordered number in the range 1 to n. So how could we do that? It's fairly simple. So at the very beginning, or the initial glance to solve this problem would be that we need to generate all the numbers from 1 to n and then lexicographically sort them and check the possibility. So but that wouldn't be the case here, because n is of order of 10 to the power of 9. So if we somehow manage to generate those numbers, then space would be, or space also would be 10 to the power of 9. And as the best of our knowledge, the sorting algorithm that we knew currently performs in O of n log n complexity. So O of n log n, that would again gives us of order, power of order 10 to the power of 9, and this wouldn't suffice because 10 to the power of 9 is very large number, and that large number we couldn't get our answer. So we just need to somehow find out the numbers in O of log n complexity. So let me just help you with understanding how this works. If our input constraints are of order 10 to the power of 5, then O of n would work fine. But if it's greater than 10 to the power of 5, then we need to suffice our solution within O of log n somehow. Log n or log n square or some kind of that. So idea in here is fairly simple. So see, if we considered every number as a separate node in itself, like 1 in itself is a node, followed by 2 in itself is a node, 3 in itself is a node, 4 in itself is a node, 5 in itself is a node, 6 in itself is a node. So if 1 itself is considered to be a node, then all the children of 1 would be having 1 as prefix and followed by the numbers. Like if it's a lexicographically smallest, then 1 is the smallest of all, followed by 10, and after 10, 1000 would be smallest, and after 1000 it would be 10,000 and all, and after 10 we would process 11, and here it would be 110, sorry, it would be 100 first, and then 110, and then followed by 10,000 and all. So if we just considered every root as a node, first of all we just need to check if this k will be coming us in the number of steps where we would be reaching to 2 from 1 by considering all these examples. So by considering all these examples, what I mean to say is, so first of all I'll just call my current to be 1, because my every time I'll start from 1 in itself, and if I started from 1, then k is already reduced by 1 because I'm already at position 1, or I'm already at this position. So k would be reduced by 1, and what I'll do is, while k is greater than 0, I'll just call a helper function. What this helper will be doing is, it will help me to find the number of numbers that are lying between this 1 and this 2. So I'll just call private int helper int n followed by long prefix 1 followed by long prefix 2. So what I'll try to do now is, I'll just call steps or numbers to be equal to 0. I'll just check my prefix 1 is less than or equals to n, because I need to check till the depth. I mean, for checking the number of numbers between these two numbers, I'll need to check all the numbers below this depth, because there are infinitely number of possible ways here, right? 100 could again give me 1000, 1000 could give me 10,000 and all. So I'll just make sure I'm just processing this until my prefix 1 is less than or equal to n. And what I'll do is, steps would be incremented by minimum of, because if r prefix 1 is itself greater than n, then that should be n plus 1 or prefix. So I'll consider either of these values minus, sorry, either of these prefix 1 or prefix 2 minus prefix 1. And once we are at that depth, then what we'll do is prefix 1 would be multiplied by 10, followed by prefix 2 also would be multiplied by 10. So I'll just need to return steps here. So while my k is greater than 0, what I'll find out here at the very beginning is I'll just call int steps is equals to, I just found out this, right, helper. So this helper of n cur plus 1, and I'll also check if these steps are lesser than or equal to k. If these steps are lesser than or equal to k, then I could proceed further. So cur would be incremented by 1 and k would be decremented by number of steps, because I already found these many number of numbers already between 1 and 2, so only remaining should be considered next. And if it's not the case, then I'll just need to go one level down, because I'll just check, I mean, if my steps is greater than k, in the sense that I already found my solution, but that's not lying between these two, and that may be much lower. So if that's present much lower, then I'll just go one level down, right? So cur would be incremented by 10 and k would be decremented by 1. So I'll just try to explain this with the help of an example that would give you more clarity. So this is working fine. So let me just consider the first example. So given our n is equals to 13 and k is equals to, sorry for not adding the comment, k is equals to 2. So we need to find the second smallest lexicographical number. So how could we do that? Is fairly simple. So initially my n, or the value at the beginning is 1, followed by 2, followed by 3, followed by 4, followed by 5, followed by 6, right? So my current initially is 1, and I already knew that I am considering one node, so my k should be decremented by 1 again. So k would be what in this case? K would be 1 only. So if k is 1 and my current is also 1, I'll just count the number of steps. So helper of, what it would be calling is helper of n. So what would be my n? N would be 13, cur would be 1. What is the cur plus 1 value? It would be 2. And I'll just store the state over here. My k also would be 1, right? So helper of 13, 1, 2. So what would be the helper of 13, 1, 2? I'll just write it above to this solution. Helper of 13, my current prefix being 1 and prefix 2 being 2. So I'll just check if my prefix 1 is less than or equal to n. So 1 is less than or equal to 13. So if 1 is less than or equal to 13, then what would be the steps initially? Steps would be what? Minimum of prefix 2, and that's 2 minus 1. So that would be what? 1 in itself, and again prefix 1 would be multiplied by 10, and prefix 2 also would be multiplied by 10. So here prefix 1 itself is also less than or equal to 10. So if prefix 1 is less than or equal to 10, what would be the case? Prefix 1 in itself is less than or equal to 10, then steps would be what? Minimum of n plus 2 and prefix 2. So what is the minimum value of both of these? And that's n is 13, so it would be 14. So 14 minus 10 would be the answer. So what would be the steps? 4, and initially steps are 1, so 5 is the answer. So we'll just return 5. How this 5 is coming is fairly simple. So see, if we just consider this example, 1, 10, 11, 12, 13, 2. So how many numbers are there? In total 5 different numbers are there. So if you just consider this 1, 10, 11, 12, 13 and then 2, because we are just considering 13, a number still 13, and after 13 we'll have 2. So these are the 5 numbers that we got. Sorry, these are the 5 numbers that we got. So initially our steps should be 5 if everything is going as expected. So I'll just call steps R and steps followed by NL. So steps are 5 initially. So initially our steps are 5. So if our steps are less than or equal to k, if steps are less than or equal to k, then uh, what's the value of steps here? 5 is less than or equal to k, then we would current increment current by 1. But if it's not the case, then we'll go one level down, right? So curve would be multiplied by 10, and we get the answer minus minus. So k minus minus, and now we are ultimately at our answer. So that's how it works. So this is fairly simple, right? You got my intuition what I'm trying to do. I'm just finding out the number of numbers with the given prefix that are possible between the current number and the next number. So if my number required or k steps, if that could already be sufficed, then I'm just going one level down. If that couldn't be sufficed, then I'm just decrementing that number of steps and I'm incrementing current. So that's how it should work. Feel free to add anything in the comment section if you think anything is unclear. And also I'm just specifying my C++ compiler not to import any libraries from C. That will be helping me to take input or give output anything to the terminal. So my cn.tie should be null, cout.tie also to be null. I'm just submitting this out. So feel free to add anything in the comment section if you think anything is unclear. Thanks a lot for watching the video. We bet 100% people with our complexity.